Let us now quickly try and establish a definition for the NOT operator or the NOT gate. In this situation, we have the following. We have a light bulb labeled A. We have a table that has a statement, bulb A is on. And we have a NOT gate, which is the symbol for which is a triangle with a bubble on it. So my light bulb being on, either being a true or false statement, is my input, and the output is going to be bulb A is not on. Right, the statement bulb A is on is either going to be false, which we will represent by a 0 in the column, or it can be true. Because there's only two possibilities, it's either going to be false or true. There are only two permutations at this stage. Let's see now what happens if we bring our special pair of goggles called not on and look at the light bulb through the point of view of the not on question. At the moment, the situation we have is that bulb A is in fact not on, being false, or rather is not on. Rather, in other words, bulb A being on is false. If I now look at it through the perspective of the not on lens, bulb A is not on is in fact now a true statement. Suppose we now in fact flick the switch and bulb A now turns on. The statement bulb A is on is now in fact true. So let's see what happens if I apply my not on goggles to the question, is this true or false? So I'm looking at the bulb A through my not on goggles. Is the statement A is not on true or false? The answer is that is obviously false. So therefore I fill in a 0 in the column bulb A is not on. So as you can see, when the bulb is on is false, the statement bulb A is not on is the logical opposite. It is obviously then true. So this brings us to the conclusion that the NOT gate simply takes the state of whatever goes into it and flips it, it toggles it. So in other words, falses become trues and trues become falses. Or alternatively, quite logically, zeros become ones and ones become zeros. That is the NOT gate.